Hey there, welcome back to Mac Tech. Today I'm going to be going over the concept of EtherChannel. So I want to direct your attention down here to these two switches. Now this is the only EtherChannel link that I have on this topology. You're never going to use EtherChannel when there's only one switch. However, down here, obviously, we are connecting these two switches together, and if you look right here, we have 4 different cables doing so. Now, you may have noticed that these cables here are dotted, and for instance, these cables here are not. The reason that is because these cables that form the ether channel are what's known as crossover cables. Um, Typically, crossover cables are said to connect like devices. Now, a like device would be, switch to switch, or you can see up here we have another crossover cable connecting router to router. They're like devices, right? Now, if I were to connect a PC directly to this router, that would also need to use a crossover cable because they're considered like devices. You can think of switches as being kind of dumb, and PCs and routers as being smarter, because PCs and routers operate on layer 3 of the OSI model. Therefore, they are able to build an ARP cache and are able to resolve MAC address to IP address. However, switches can't do that. Switches only know MAC. It's the only language they speak is MAC address. And instead of mapping IP to MAC, they map MAC address to switch port. Okay. So that being said, we have 4 crossover cables connecting these two switches down here. And what we're going to do is we're going to make all of these crossover cables act as one single connection, right? So though we have 4 cables going back and forth, all of them are going to act as one cable essentially, and that's going to increase our bandwidth and provide redundancy. So basically, if one link were to go down, it would be okay. We would still have our Ether channel operating. We'd still be able to pass communication between these two devices. Now, I don't know if I mentioned in the last video, I forgot, but right now we have our sub interfaces here at the router configured. So these PCs have a default gateway. So if I were to ping, for instance, let me grab the IP here. If I was to ping this PC to this PC, it should work. And I'm going to test it out. Beautiful. Okay, so you see it's replying. So my packet goes out to here. Switch says, oh, I need to send this to the default gateway. Default gateway then sends the packet back down to our destination, okay? But if you notice, this is VLAN 19, so I'm able to ping within my own VLAN. However, or you know what, and I also should be able to ping this VLAN because they're connected to the same default gateway, or I'm sorry, the same router. So let me go ahead and test that. Let me grab an IP here. So I'm going to do ping. Should be doing the ARP request. And there we go. Then we have the replies. So basically data went to the switch, up to our default gateway, back down, and then to our VLAN. Remember, we're able to communicate across VLANs because we have a router on a stick configured right here. Okay. However, because these PCs don't share a router with these PCs over here, these two VLANs, I'm not able to communicate because when I send a message out from, say, this server here, it's going to go here, it's going to go up here, it's going to come back down, right? And we haven't configured our Ether channel yet. So as far as these networks are concerned, they are completely segmented. So just to prove that to you, I'm going to grab the IP of this server, and then I'm going to go over here to this server, and I'm going to try and ping. And it shouldn't work. Okay, 3 timeouts. It's not going to work. Okay, because data goes here. Where's my default gateway? Oh, it's up here. Sends the data to the default gateway. Default gateway says, okay, I'm sending it back to the destination. Comes down here. There's nowhere to go. The switch is not seeing that mapping, that MAC address to port mapping, because we cannot communicate from this network to this network. They're not able to talk because we don't have an Ether channel connected here. We don't have an, even it would work over one link too. If there was just one cable that was connected here forming a trunk, it would work. But it's not. It's not connected. It's not configured as a trunk, so it's not going to work here. And that wouldn't be a problem. That wouldn't be a problem if we had routing established, which we don't have routing. So this sub interface down here has no way of getting to this sub interface over here because we have not established routing. We are able to ping from the SE001 interface to the SE000 interface because they're directly connected. But this network and this network here, this network and this network, for instance, they're not directly connected. They don't know about each other. Okay. So what we're going to do is we're going to fix that at layer 2. Now later we are going to configure routing, but for today, we're just going to configure this layer 2 trunk, or it's called a port channel. Ether channel, the physical link is described as a port channel. Okay, so let's get started with configuration. So we're going to put in our username and password. Okay, so as you can see here, I have the commands listed in the text file. So we're going to do conf t or configure terminal. Okay, and so it looks like I forgot to specify. Oh no, I didn't. So interface range. This way we can configure more than one interface at a time. It just saves time and it helps you to reduce the errors you make. So interface range 1 through 4. We already went over what switch port mode trunk means. So we're making port 1 through 4 a trunk port, and these are going to be the VLANs that are going to be allowed to go across. Okay, so let's go ahead and paste those in. Okay, now you see here interface port channel 1. So what this does is that it creates an interface called a port channel. Now the port channel, right, like I said before, is this single logical interface comprised of multiple cables, right? Multiple cables, multiple ports. The ports here. Let me do this. So these 4 ports, interface 1, 2, 3, 4. From the perspective of the switch and from a logical standpoint, they are all going to be treated as the same interface. So in this case, the fast Ethernet interface allows for 100 megabits per second. That's the speed. With all 4 of these stacked on top of each other, we're going to get 400 megabits per second as the bandwidth, or as a speed rather, because they are all going to be logically connected. And also more data is going to be able to move through logically because we have, so much more physical, physical channel for data to flow through. Okay. Okay, let's get back to what I was talking about before. So yeah, I'm going to go ahead and create this port channel. Okay. And then I'm going to do these commands. Let me explain this. I went back to the interface configuration for fast Ethernet 1 through 4, and then I invoked this command here, channel group 1. So channel group 1 mode active basically assigns these ports to this port channel. That's what channel group 1 does. Okay. Mode active. Okay. So there's 2 types of port channels, or I'm sorry, Ethernet, or sorry, Ether channel types essentially. There's LACP and there's PAGP. So LACP is Link Aggregation Protocol. That is going to be the Ether channel type that is common across vendors, right? So if we did a Cisco switch to a Juniper switch, we'd be probably using LACP for that reason because it's compatible across different types of vendors, right? PAGP is Port Aggregation Protocol, I believe. I could be wrong, but it's a Cisco specific protocol. So if you did a Juniper switch to a Cisco switch, it's not going to work over PAGP. Juniper switch isn't going to be able to understand that language to say. So we're using, this is an example of LACP because the LACP modes or are the different states for the LACP interfaces are active and passive. Active is going to actively seek out a connection. So if I had active over here, it's going to ask this guy over here, hey, you there? Let's form a port channel. Let's form a channel group. It's going to actively talk to it, right? The other one's going to be passive, and we're going to configure this IT switch 2 to passive. Passive isn't going to, by definition, by by the word it means, is like it's not going to actively initiate a session. So if I had a passive LACP channel group over here, and I had a passive LACP channel group over here, they're never going to form an Ether channel because neither side is initiating the connection. It would also work too if I had active over here, active over here. But for the sake of showing you both configurations, I made this side active and this side passive. Okay. All right. So we'll end. Okay. So I'm going to go to switch 2. Okay. So I'm just going to paste in the commands from this point. Configure terminal, get us into global config mode. Interface range. We're going to make these switch ports into trunk ports. We're going to allow these VLANs over the trunk. All right, now we're going to create the port channel 1. Remember, the port channel needs to be the same on either side. So port channel 1 interface is created. And then we're going to paste in these final commands here, which is going to take us back to the interface range 1 through 4 and channel group 1. So these are going to be on the same channel group. It has to have the same channel group in order to initiate a connection. Okay. And let's see here. So we'll do show IP interface brief. And we'll see our port channel is created here. It wasn't there before. Until we invoke the interface port channel 1 command, this interface would not be here, right? But it's showing down, right? And it's pretty obvious as to why. Fast Ethernet 1 through 4 are administratively down. So administratively down just means that they've been shut down by me at some point. So let's do this. Let's go back to interface range, fast Ethernet 1 through 4. Oops, we're not in global config mode. Let me change that. Paste it again. And we're just going to do no shut. Okay. So they're showing down. I wonder if they're down on the other one too. Yes, they are. I don't know why I didn't notice that last time. Let's just do this. Show IP interface brief. There's our port channel. And yeah, fast Ethernet 1 through 4 are administratively down. So let's do the same thing on this side. No shut. Okay, cool. So yeah, you see here, fast Ethernet 1, up, 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 and look at that. Our port channel is up. Cool. All right. So next we're going to move on to our verification commands. So I'm going to go ahead and get back to this mode. Okay. So let's do the first command here. Show ether channel summary. Okay, perfect. So here we're going to see our channel group 1, our port channel 1, and SU. That means it's up. That means it's up and active. Now we're going to run this other command. Okay, great. So as you can see here, it's also going to show our interfaces. It's going to show their state, active, 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 active. Perfect. Okay. Now we're going to go back to this side. Show ether channel summary. All right, same thing over here. We're looking good. Last verification here. Passive, 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 passive. Awesome. Okay. So in theory, at this point, we should be able to go to this VLAN 19 here, and we should be able to use this port channel to ping a different VLAN on this connected to this other router. So in this case, we'll try to ping VLAN 21 from VLAN 19. Or rather 19 from 21. It should work now. Let's let it do its ARP requests. And there we go. Now we have connection. Now you might have noticed that time you saw 2 request timeouts. So the reason for that was because we had to go up here, said, hey, default gateway, where are you? So I had to know where had to ask, send an ARP request out for the default gateway. And then it gave it the response. And then once it discovered the default gateway, it then had to discover this other PC. So there was 2 different ARP requests that had to happen before the ping could successfully initiate an echo response. Okay, well I hope that cleared some things up with Ether Channel. Appreciate you tuning in, and I'll talk to you next time.